All right, so this question is a little bit tricky and it might seem a little bit simple on the surface. It might also seem like there's not enough information, but there actually is. Okay, so this is a question that one thing that I want you to be able to do very quickly is to narrow it from 3 options down to 2. Okay, so this question is asking what is the order of our reaction? We know the order of our reaction is going to be 0th, 1st, or 2nd. Now, what this tells us is this tells us our decomposition and our concentration change of our NO2. And we see that our times are every 5 seconds the concentration was measured, and we see the concentration go from 0.1 to 0.017 to 0.009 to 0.006 to 0.005. So it goes from 0.1 to 0.005 very quickly. Now, one thing that I want you to be able to do is look at this data and say these 2 times and these 2 times. The time change between them is the exact same. It's 5 seconds. Then if you look at the concentrations between the 0 and the 5-second time point, our concentration drops roughly 80%, a little bit more than that, but it goes down by 0.083. Then our next change, our concentration drops in half, basically. Now, what that allows us to do is eliminate a 0th order reaction as an option. This is not a 0th order reaction because of the fact that our time intervals are the same and the change in our concentration is different, because a 0th order reaction would look something like this, would have a concentration difference that goes 0.1 to 0.09 to 0.08 to 0.07. Basically, the concentration is going to go down at the exact same frequency or at the exact same amount over the exact same time frame. So I'm going to go ahead and erase this because that is off the table. It's not a 0th order reaction, but instead it's a 1st order or a 2nd order reaction. Now, the good thing about this is that all that we really need to do is play with the numbers a little bit. Now, one thing that's important for you to know is the graphs for a 1st order and a 2nd order reaction. If we take the natural log of a reactant and graph it versus time, we're going to have a nice linear graph that looks a little bit like that. It's a negative slope, but it's linear. So that means if 5 seconds pass and the concentration drops by this much, then 5 more seconds, the natural log will drop by this much, and 5 more seconds, the natural log will drop by this much. And so it's consistent. Now, what we see here is, so that's our 1st order reaction. 2nd order reaction would be something like this. 1 over A versus time would give us a positive slope, a positive linear slope. Now, what we are going to do for this in order to solve this is I'm going to take the reciprocal of my concentrations and I'm going to solve them. So 1 divided by 0.1 is 10. 1 divided by 0.017 is 58. I plug that in my calculator here. 1 divided by 0.009 is 111. 1 divided by 0.006 is 166. Okay, 166. I'm just going to stop there. Now, what I want to do is I want to relate this to time. Now, if I see a 2nd order reaction, or if this is a 2nd order reaction, then this change right here, and this change right here, and this change right here, when I relate them to the time, the 5 seconds that pass, that number should basically be the same, or very close to the same. And so what I'm going to do is I'm going to say 58, which is 1 over 0.017 minus 10. So that's my difference there. Divide that by 5. and I get that this difference is 9.6. Now, the next thing that I'm going to do is take 111 and subtract that 58 from that, and divide that by 5. Now, if this is a second order reaction, the change, that ratio should be approximately, 10-ish. It should be close to 10. Okay, so what I'm going to do is I'm going to plug that in, 111 minus 58 divided by 5. I get it's 10.6. Okay, so fairly close. Then 166 minus 111 divided by 5, and I get 11. Okay, so what that tells me is that my rate of change is, well, between the first 5 seconds, the next 5 seconds, and the next 5 seconds, they're all fairly similar to one another. They're all fairly close. I see a subtle increase, but it's still fairly close. Now, what I'm going to do to compare that, and so basically if I were to plot this data right here, or sorry, if I were plotting this, I would plot it basically as 10, 58, 111, 166, and there's my graph. Now, what I really want to know is how linear is that? Is that more linear than a natural log of the concentration versus time? And so what I'm going to do is I'm going to plug in the natural log of 0.1. That gives me negative 2.3. And then I'm going to type in the natural log of 0.17. And that is negative 4.07. Then natural log of 0.009. And that is negative 4.71. I can divide all of these by my times. So divide those differences, 4.07, 2.0, by 5. That is approximately 0.46. And then that's a negative 0.46, and then next is negative 0.814, and then negative 0.942. Okay, now I did this because I wanted to find out basically what my change was for a time frame. Now, what this shows me, this data point, or this information right here, is that the natural log of my concentration changed, it doubled. And after the first 5 seconds, and then after the next 5 seconds, it didn't double. Okay, so if I were to plot this, it would look a little bit like this. All of this data looks like that, compared to all of this data looks like this. So what that tells me is that whenever I plotted it as the inverse, it was more linear than when I plotted the natural log, which is an indication that my graph, my second order graph, is a little bit more linear and therefore more accurate. So this is a second order reaction. Now, I think that it's important to just kind of look at the data and see the drop off. So like I said about the 0th order, it changes the exact same amount every single, time frame. Well, here we see a pretty dramatic drop off. We see the concentration drop by 80%, then drop by 50%, and then drop by a little bit less. So we see a very dramatic drop off, and then a little bit less, a little bit less, a little bit less. So that's a good indication that it's a second order reaction. All right, I hope this is helpful. I'll see you on the next question.